Good afternoon to all the attendees of this session. Myself, Archana Kaushik, Assistant Professor in the Department of Commerce of IIMT College of Management, Greater Noida. The topic for today's session is time value of money. Although this topic is difficult to digest in just half an hour, but still, I will try my level best to justify with it and make you understand well. So let's start the session with the learning objectives. After the completion of the session, you will be able to learn why money has time value, the concepts of simple interest and compound interest, different types of cash flows, compounding and discounting concept, future value of single amount or lump sum, future value of annuity, future value of present value of single amount or lump sum, present value of an annuity, doubling period, and benefits of time value of money. So before we start the session, let's start with the particular case. We have two situations before you. First option is you may receive 10,000 today or you may receive 10,000 after 1 year. Which option would you opt for? It's but natural we all will go for first option because you are getting rupees 10,000 today itself. But regarding option B, you are getting same amount after 1 year. It's better to go for option A because with this particular amount, you can fulfill your three objectives. Number one, you can utilize it for current consumption. You can make investment of rupees 10,000 to earn real return. And number three, you are avoiding your risk also. So it's better to go with option number A. Now consider second situation. You have again two options. First option is receive 10,000 rupees today. And second option is you can receive 20,000 after 3 years. Which option would you opt? Now this time you can give a second thought to the option number B. Why so? Because you are getting 100% return on your investment of 10,000 which you are making it today and you will get 20,000 after 3 years, right? So if you are sacrificing your rupees 10,000 today against your current consumption, against your investment, against the risk, so what you are getting 20,000 after 3 years. So it's a win-win situation. Everybody would like to go for option number B. But the point here to note is you are investing or you are sacrificing 10,000 of today for 20,000 after 3 years. This means what? You are getting extra amount of rupees 10,000. What is this 10,000? This 10,000 is nothing but the time value of money, which in finance we use a term interest. We always used to take loans. Yeah, we make investments. So whatever interest we get, this interest is nothing, but it's just the time value of your investment or it's a time value of your borrowing. So let's start the session. Why money has time value? This is the question. So I've already discussed that money has time value because current amount could be utilized for current consumption. Number two, it could be utilized for making investments so that you can earn real return. And number three, you can cover up your risk also. Next is simple interest and compound interest. Although you got the idea that what is time value of money, it is nothing but interest. Interest could be of two types, simple interest and compound interest. Okay, we all know what is simple interest. When we calculate the interest on principal amount, it is known as simple interest. For every year, we always calculate interest on principal amount only with the help of formula P into R into T upon 100. On the other hand, in case of compound interest, what we do? We basically use the principal amount plus interest amount and then we calculate the interest. That means in case of compound interest, we always get interest on interest. That means apart from principal, we also get interest on interest amount also. So in finance, what is the point to consider is in finance, for all type of decision, whether it's decision of capital budgeting, whether it's a decision of cost of capital, valuation of securities, whatever it is, okay, for every decision, we are concerned only with the compound interest, not the simple interest. So whenever we talk about interest in finance, we are only concerned with the compound interest. Next is how to calculate compound interest. For example, suppose we have principal at the beginning of the year, rupees 1,000. right? After getting interest of 10%, it will become 1,100 rupees at the end of year first. At the beginning of second year, we have principal in hand, rupees 1100. On this particular principal amount of the second year, we will add interest, which would be calculated on the 1100, not on 1000. That means we are calculating interest on interest amount plus principal amount. Similarly, in the third year, principal at the beginning of third year would be 1210, right? On this 1210, we again put interest at the rate 10% and we'll get again 1 to 1. So in case of simple interest, what would have been the interest? 100, 100, 100 for all the 3 years. But in case of compound interest, this interest goes on changing, goes on increasing. First year, it would be 100. Second year, it would be 110. Third year, it would be 121. And for this calculation, we have simple formula A into 1 plus R to the power n. So we can simply write principal amount multiplied by in bracket 1.10 to the power 3, and we will get 1331, which is same as our calculation. Next is types of cash flows. For any transaction in finance, we can only have these three possibilities. We may go for single payment, we can go for unequal payment, and we can go for equal payments. If we are, for example, if we are investing amount today and we want to calculate its value after 5 years, this is a case of single payment. On the other hand, if we are making investment just like in SIPs or in mutual funds, what we do is we used to make equal amount or unequal amount on different time periods. For example, you make payment of 1,000 rupees today, next year you make 2,000, next year you make 3,000. So all these are unequal payments. So this is the second condition. And third condition is you are making uniform payment all the years. For example, 10,000, 10,000, 10,000, and so on till your period of investment. So this is the case of annuity. So in finance, we have only three possibilities of cash flows: single payment, unequal payments, and equal payments. The other name for equal payment is known as annuity, and this annuity could be annuity certain or annuity due. So what is annuity certain? If we are making investment and if we are making cash flow at the end of the year, then it's the case of annuity certain. On the other hand, if we are making payment or if we are making investment at the beginning of the year, that is the case of annuity due. Next is timeline. In time value of money, timeline is very important concept. What we do is we used to display our cash flows in the form of timeline, which is represented as 0, 1, 2, 3, and 4 periods. Okay, and it's a case of annuity which is certain because we have 100, 100, 100 same amount. That means it's the case of it's the time value of it's the timeline of annuity certain. And because why it is uncertain? Because we are making payment at the end of the year and interest rate is 10%, which is nothing but the time value of money. So this is the way of presenting our cash flows in timeline. Next is compounding and discounting concept. So this interest, that is compound interest in finance, could be utilized for either compounding concept or for discounting concept. If we are concerned with calculating the future value of our investment, we are using compounding technique. On the other hand, if we are concerned with calculating the present value of our inflow, which will be receiving after 10 years, we are concerned with the discounting technique. So the compound interest which we are using for calculating future value, it is known as compound interest as it is. On the other hand, when we are using it for calculating present value, we will call it as discount rate, right? Next is we are concerned with the compounding technique. So we have again three flows now, single flow and annuity. So we are concerned in this session only with the single flow and annuity. So this is the case of future value of single amount. That is the power of compounding. Example is, suppose you deposit 1,000 rupees today in a bank, which will pay you interest compounded annually at the rate of interest 10%. How much will the deposit become after 8 years or 10 years? The first way, we have three ways of doing this calculation. In the first way, we can use simple the formula A into 1 plus R to the power n. That is 1,000 into 1 plus R. R is 10% and number of years is 8. So we will put here 8 and we'll get the value 2143.58, which we can calculate with the help of calculator very easily. Second way is how to calculate. The second way, we can use the finance tables. Finance tables are easily available on Google. You can easily Google it and you can get the values of future value interest factor. So we have basically 4 tables: FVIF, FVIFA, PVIF, and PVIFA. We'll consider later on. The first is, since this is a case of lump sum, so we will consider the future value interest factor table. So what we'll do is we will multiply our principal amount, that is 1000 rupees, with the future value interest factor 10,8. 10 is interest rate and 8 is number of years. You will get 1000 to hai aapke paas 2.144. How it comes? See, this is the future value interest factor table. In case of 10% interest rate in the year 8, you are getting 2.144. Right? So you will pick this particular number and you will put it here and you will get 2144, the future value of the lump sum. Third way is to use the Excel application. That means you can use the Excel sheet to calculate the future value of lump sum. How it is done? I'm just showing it. See, you have an Excel sheet. Isme we have A, B, C columns and 1, 2, 3, 4, 5, 6 number of rows. In Excel, we have inbuilt function. So you just have to put, you just have to write equals to FV in bracket. So automatically Excel function will come and you will have to put all the details like FV and C4, C3. C4 is column 3 and row 4. C3 is column 3 and row 3rd. इसमें क्या है? You have in C4 we have 55650, that is the investment amount. In C3 we are mentioning the interest number of years. 0 is basically PMT, we will put 0 here, and minus C2 is minus C2, the present value of the investment 55650. And lastly type we can put 0, and once we put enter, press enter, we'll get the value 225135. So it's very simple. Just you have to write equals to and FV. Excel will give you the formula and you have to put the figures as per the your data in the formula and press enter. You will get the answer as simple as it is. Next is future value of annuity. We have done the case of lump sum. Now we are going to see the case of annuity. Suppose Mr. X deposits rupees 1000 annually in a bank for 5 years and he is going to earn an interest rate of 10%. What will be the series of deposit? What will be the future value of series of deposit at the end of 5 years? Since he is making investment of 1000 rupees annually, it's a case of annuity. It's a case of annuity certain, right? And interest rate is 10% and number of years is 5. So what we are going to do? Again, we have 3 ways. First way, we can use table formula. So we can put A into FVIFA R comma N. Earlier we did FVIF. Now we will do FVIFA. Again, in Google, you have the tables available. Future value interest factor annuity. You simply have to put 1000 rupees multiplied by this figure you will get from the table. Let's see how it is. Number of years are 5 and percentage is 10. See, number of years is 5 and percentage is 10. We are getting 6.105. So we'll put 6.105 in the formula and we will get 6105 as the future value of annuity at the end of 5th year. Second way is simple. We can use the formula approach. We can multiply A, that is our investment, multiplied by formula is 1 plus R to the power n minus 1 upon R. And we can put all these figures in the formula, that is 1 plus 0.10 to the power 5 minus 1 upon 0.10. We'll get 6.105. With the help of scientific calculator, we can easily get this figure 6.105. So again, when you multiply 6.105 into 1000, we simply get 6105. This was the second way. Again, third way is using the Excel sheet. So simply here we have an Excel sheet inbuilt formula for future value. Again, same formula will be put in the Excel sheet. Yes, equals to FV. Once you write equals to FV, formula itself enters on the Excel sheet. You have to just press the enter, and you will have to enter all the details of your data. That is FV in bracket C3. C3 is column number 3. In column number 3, we have interest rate, C4. In column number C4, we have number of years, minus C2. Minus C2 means the investment you are making annually, rupees 5,000. And PV is 0, type is 0. After putting all these figures, once you press the enter, you will get the value 21873. So we have done with the future value of lump sum, future value of annuity. This is the case of PPF. We are making investment in PPF for rupees 30,000 per year for 30 years. You want to calculate the value of your PPF account at the end of 30 years. If we are getting 8% interest rate, so it's very simple. You can use the PVIFA table and you can multiply with your investment which you are making every year for 8% interest rate, and 30 years is the number of periods. We can use this particular formula approach also. We can use the table approach also. And after applying the formula or table approach, you will get the value 33,98,490, which you will get after 30 years of making investment in PPF account. Now we are done with compound value. Now we are concerned with present value. If we are considering present value, again we have single amount or annuity. So first we'll do single amount. Suppose you will receive 50,000 after 10 years. So here in this case, you are getting this amount after 10 years and you are concerned with calculating the present value of this particular amount. So you are getting 50,000 after 10 years from a bank, in which you are getting interest rate of 15% compounded annually. You want to calculate how much will be the amount of current investment. That means you want to calculate the present value of this rupees 50,000. So again, we have three approaches: formula approach, table approach, and Excel approach. So in formula approach, just opposite of future value of lump sum, we have A upon 1 plus R to the power n. So what we'll do is we'll put 50,000 upon 1 plus 0.15 to the power 10, and we'll get simply with the help of calculator 12,359. On the other hand, if we apply table approach, what we'll do is we will use PVIFA table, PVIF table, A into PVIF table. I repeat, it's available in Google. It's very easy. You can download it or you can use it for your calculations. So you can put rupees 50,000 multiplied by PVIF 15, 10. I can show you also. PVIF table is this. Interest rate is 15% and number of years is 10. So let's see, 15% and number of years are 10. This is the value 0.247. We can put it there, 0.247C, and after multiplying this with 50,000, you are getting 12,359. As simple as it is. Third way is we can use again Excel sheet with the help of inbuilt formula. In the Excel sheet, we can just write the formula. Instead of FV, this time we will write PV. So we will write equals to PV in bracket rate, comma NPER. NPER number of periods है. PMT is payment. FV is basically the जो आपने investment किया है, and type is 0. So once you put all these figures in the Excel formula, you will get the value 13750. Next is present value of annuity. The case is, suppose Ram expects to receive 1,000 annually for 3 years, and each payment is occurring at the end of the year. And you want to calculate what is the present value of this stream of benefit if the discount rate is 10%. So first way is formula approach. Here the formula will get differ. Formula is 1 plus R to the power n minus 1 upon 1 plus R to the power n and multiplied by R. So we'll put all these figures, 1000 into 1 plus 0.10 to the power 3 minus 1 upon 1 plus 0.10 to the power 3 into 0.10, and we'll get, with the help of scientific calculator, you will get the value 2487. If it is difficult one, you can use the tabular approach, but this time you will have to apply PVIFA table, that is present value interest factor annuity table for interest rate R and number of years is n. So in this case, we have 1,000 rupees of amount which we are getting, and 2.487 is the table value, which we can see with the help of next slide. Number of years are 3 and interest rate is 10. Let's see. Number of years 3 and interest rate is 10, 2.487. We can easily use this particular figure in the question, and we can get the answer 2487 as simple. Third way is Excel approach. So again, we have formula equals to PV, rate, NPER, PMT, FV, and type. We can put all these figures in the formula that is equals to PV. Rate is mentioned in column number 3. NPER, number of periods, is mentioned in column number 4. See, this is 4. And minus C2. C2 is your amount of investment for your earnings which you are getting. So C2 is mentioned in column number C2, you are getting rupees 1000. And again, FV and type will put 0 and 0, and you will get the amount 15850. So in Excel, it's very easy. You can just put equals to and PV. You will get the whole formula. Just press enter, and you will have to put all the details of your question. And after pressing enter, you will get the answer by simple click. Next is doubling period. Very, very important. In finance, we want to determine in how much time period our investment will become double. So we have two rules, rule of 72 and rule of 69. If we apply rule of 72, what we have to do is formula is 72 upon interest rate. Say for example, if you are getting an interest rate of 15% on your investment, so with the help of thumb rule of 72, you can use 72 upon interest rate 4.8. So you can easily calculate that in 4.8 years, your amount of investment will get doubled. More accurate way is rule of 69. In this case, formula is 0.35 plus 69 upon interest rate. Again, same case, it's a interest rate you have 15%, and the formula is 0.35 plus 69 upon 15, and the value is 4.95. It is more accurate as compared to rule of 72. But these both the rules are very applicable in finance. So interest rate, for example, interest rate of 10% and doubling period is 7.25. You can easily get this. कैसे किया? 72 upon 0.10 and you get 7.25, as simple as it is. Lastly is benefits of knowledge of time value of money. In finance, we have so many decision making activities like we have capital budgeting, we have cost of capital, we have valuation of securities. We need to compare investments from where, in which type of investment we are going to make investment. So in those particular decisions, time value is very, very helpful for us. So number one is for investment analysis to decide among the projects. Number two, to compare the investment alternatives. And number three, to analyze how time impacts business activities such as loans, mortgages, leases, savings, and annuities. So in this session, what we have studied is, we have studied why money has time value. What do you mean by time value of money? It's just the compound interest, nothing else. And why we are using time value of money? We can use it for different activities like capital budgeting, like cost of capital, etc. And how we can use compound interest in compounding technique and in discounting technique and for different types of cash flows. So that's all for now. Thank you so much.